Hello everyone. In this lesson, we are going to use implicit differentiation to solve for dy dx. Step number 1, we differentiate both sides with respect to x. Step number 2, we are going to use the chain rule. And step number 3, we're going to solve for dy dx. So let's do example number 1. Now remember, we take the derivative of both sides with respect to x. So we do 2x dx dx, which is just 1, plus 2y dy dx, and the derivative of 25 is 0. So we have 2x times 1, which is x, or the derivative of x squared is just 2x, plus 2y dy dx equals 0. To solve for dy dx, I subtract both sides by 2x. So I have 2y dy dx equals negative 2x. Now divide both sides by 2y. 2y, I have dy dx equals negative x over y. We need to write dy dx in terms of x. So let's solve for y. Let's go up here and say x squared. Let me do that in a different color. X squared plus y squared equals 25. Y squared equals 25 minus x squared. And y equals square root of 25 minus x squared. We can substitute y into our equation. So we can say dy dx equals negative x over y, or dy dx equals negative x over the square root of 25 minus x squared. And that is the function of the slope dy dx written in terms of x. From example 1a, we found the slope equals negative x over y. That is dy dx equals negative x over y. Now we can use the slope and find the equation of the tangent line to the point at 3, 4. So the slope function using substitution, dy dx equals negative 3 over 4, and that is the slope of the tangent line at the point 3, 4. And if we want to find the equation of the line, we say y minus 4 equals negative 3 over 4, that is the slope, times x minus 3. And that is the equation of the tangent line to the graph at the point 3, 4. In example number 2, we are going to find the derivative dy dx of the function with a mixture of two variables x and y. Notice that we don't have to solve for y in terms of x. We can just use implicit differentiation and start solving. Now first, I take the derivative d dx of both sides. So d dx of sine of x plus y and d dx of y squared times cosine of x. The derivative with respect to x is going to be cosine of x plus y times x plus y prime using the chain rule. The derivative of y squared times cosine is going to be y squared prime cosine of x plus cosine of x prime times y squared. So I have cosine x plus y times the derivative of x is just 1. The derivative of y is 1 times dy dx equals 2y times dy dx. Notice whenever I take the derivative of y, I must multiply by dy dx. And here also 2y times dy dx. The derivative of y squared is 2y times dy dx times cosine of x plus the derivative of cosine of x is negative sine of x times y squared. Using distribution, I have cosine x plus y plus cosine of x plus y times dy dx equals 2y cosine of x dy dx minus y squared sine x. Now I subtract both sides by 2y cosine of x dy dx minus 2y cosine of x dy dx, and I subtract both sides by cosine x plus y minus cosine x plus y. I have my new equation is going to be cosine x plus y dy dx minus 2y cosine of x dy dx equals negative y squared sine of x minus cosine of x plus y. Notice the 2y cosine x dy dx get canceled. So now I can factor out the dy dx. When I take dy dx out, I have dy dx times cosine of x plus y minus 2y cosine of x equals, and take out the negative 1. So I have y squared sine of x plus cosine of x plus y. To solve for dy dx, I will divide both sides by cosine of x plus y minus 2y cosine of x, both sides, cosine of x plus y minus 2y cosine of x. So dy dx equals negative parentheses y squared sine of x plus cosine of x plus y all over cosine of x plus y minus 2y cosine of x. Or distribute the negative 1 through the denominator. We have y squared sine of x plus cosine of x plus y all over negative cosine of x plus y plus 2y cosine of x. And that is our answer for y prime or dy dx. Good luck on your homework, and I will see you in the next video.